We are studying week 1 of course 1 of deep learning specialization. And let me elaborate more on this aspect. What is AI? Introduction. Okay. So I organized some of the slides here, and let me just elaborate more. So Andrew Ng talked really nicely about how transformative AI is going to be. And I talked about that in the previous slide. Let me just build a bit more on that. Okay. So these are slides from his 2022 version of CS230. All the links you can find on his website. You can also find them, just simply Google them. So I've just taken them as is. So AI is a general purpose skill. This is very important. So AI and deep learning. So anything which we say for AI also applies for deep learning, right? So it's not everything we say about AI is gonna be true for just a second. Wrong. Not everything we say about deep learning might be true for AI, but everything we say for AI will probably be true for deep learning. So something like this. AI is a superset, then deep learning is subset. Deep learning is one of the ways you could do AI. Okay. Now, AI is nothing but artificial intelligence, right? Just as the term says. So you see, if intelligence is so valuable, so is artificial intelligence. So all the things we have, all the companies we have, all the jobs we have, whatever domain they're in, we can use AI and deep learning there and add a lot of value. So this is, AI being a general purpose skill. You can easily check and see any research paper output. You will find that the applications and implications of this are huge. Okay. So because every domain can be improved by AI, now you have two options. You know, if you come from any different domain, you can learn AI and you can do state of art work in that domain. Okay. Or if you are from just deep learning, if you are from computer science, you master deep learning as one of the ways of solving problems, and then you choose a domain in whose problems you want to solve. You could be interested in video gaming. You could want to apply AI and deep learning methods to video game content, or video game related audio processing, or something like this. Or it could be search, it could be protein folding, it could be astronomy, it could be whatever, right? So every domain can be improved by AI. That's another reason to learn AI. And the thing is, AI, especially deep learning, it has become possible, feasible just now, quite recently, 2012. Okay, it is so recent that anyone who picks a domain in which deep learning has not been applied before, okay, they can most likely break the state of the art in that domain. Okay, so all you have to do is apply it to that thing, and you can easily publish a paper saying that novel deep learning application, and you have been able to take breakthrough performance. The thing is, it wasn't that research was breakthrough. It is more like the deep learning actually enables breakthrough results, right? So this is like one of the low hanging fruits. This is where strategy thing comes into picture. If you just pick the race you are participating in wisely, you can actually win a lot more with a lot less efforts. Correct. So it's the same thing here. Just pick a domain which is less crowded, and for the same skills you have now, you will be able to take their advantage better. And that is a very nice tangent from this thing which is being deep learning has broken many. So this SOTA stands for state of arts, and there is a website called as Papers with Code where you can actually check all of these state of arts, but we can do that a bit later. Okay, hopefully this is helpful. This thing was not actually mentioned in more detail by Andrew Ng in his lecture, but this is actually quite true. So let me just go to this website, Futurepedia. Okay. So these are all the tools which are actually adding value with help of AI right now. The thing is, many of these tools have been built by individuals. Before, if you wanted to include AI from 2012 to I think 2015, 16, Only big companies like Google, Microsoft were actually able to do breakthrough research because only they had that much, data, that much powerful hardware, and that much money to actually burn on running those algorithms. But AI, deep learning especially, has become powerful not only because it is just powerful, but it is powerful and accessible to individuals. So you see, you can actually solve a small problem completely with help of deep learning and actually make a product out of it, and you can have a micro product which is actually solving a problem, and you have decent enough customer base, and it is actually enough to kind of like have equivalent salary as you would have had. So it is not only powerful tool, it is also now profitable, and it is also accessible. So many reasons of learning deep learning. So these were some of them, and now when Andrew Ng talks about the deep learning section, there are a few more reasons he gives about why to go into deep learning. So this was an amazing slide. I just love this slide, which talks about subfields of AI and how has the interest in them changed over time. Okay, so first let me just go through the subfields of AI. So there are quite many, as you can see. Anything which can give us intelligence is artificial intelligence. It could be copy paste as well. Okay, let me give you an example to actually think about. Imagine you have a parrot bird which can mimic what is being said. If he was Einstein's parrot, he would be able to mimic everything Einstein is saying, let's say. But does he understand anything? No. But can he replicate the behavior of intelligence? Yes. Let's say we have a skilled person who is skilled at doing something. Let's say maybe it martial art, maybe fixing some engines, or doing some movement, and which is valuable. If that person has a monkey who learns to clone everything they do, is it intelligence? Not really, but it's a copy. Even though it's without understanding, it's still a copy, right? So there are many ways of doing intelligence. A simple hard-coded if-else is also a kind of intelligence. And all of these different ways of replicating intelligence, any of them which works is profitable, right? Because intelligence is so rare and so powerful. Wherever we apply it, we will make breakthroughs, right? We have been able to create power of sun in our labs, fusion, unlimited energy. That's just science fiction. That was result of intelligence, human intelligence, so many people working on it together. And if you can do that with help of computer, it's we have a very powerful tool at our disposal. So any field will work. Now different ways are looking in a different philosophy. So for example, if you check expert systems, this approach is about encoding knowledge of experts, just like what Britannica did for knowledge. Expert system does that for any kind of expertise. And there are very interesting things in this. Knowledge representation is a field in which we focus more on how should we represent knowledge. Okay, more than brute force, it is through understanding of how knowledge is connected, deconstructed, how does it relate to each other, and that's where the intelligence and knowledge of this thing lies. In expert system, it is dependent on experts encoding their knowledge, and once it is done, we can scale it. Okay, so planning looks at intelligence as more like a planning problem where more intelligently we plan and less wrong plans we make to reach a right answer, better we are. As you can see, all of these things are different ways of doing AI. Search phrases it as a search problem. Game theory is more like a AI in which multiple systems are interacting with each other, and it's a dynamic equilibrium between these competing things. What is an example of that? Example would be in a jungle, we have tiger and we have deer. Okay, it's not just these two, we have also bears, we have other birds. So there is a huge chain of lives ecosystem, and everything is competing against everything amongst limited resources. So dynamic equilibrium based on that situation, that geography, that certain time period, that combination somehow could have been done with game theory, right? Different things, different ways of doing intelligence. Probabilistic graphical models, what do they do? Intelligence is based on probability encoded information. So if this happens, it's likely that this might happen and this might happen, and that's how we have a language of probability, conditional probability. If this happens, then that which is related to this might have this chance, and then blah blah, very complex structure. We could have that kind of intelligence as well. We have another way of intelligence, which is we learn by doing. Try, see if it works or not. If yes, we know better. If no, we know even that we shouldn't do this. So through this trial and error, we are able to simulate intelligence. And of course, we have deep learning and machine learning. Okay. So these are very important because the thing is, there are so many, and so many of them have been improving as long as the research has been going on. Okay. But now deep learning has overshadowed all of these because of a few reasons. So reason, these things are taken, it's not just for us to remember, it's for us to understand, oh, to do intelligence there are many different ways, and scientists have done a lot of work in all of them. Now we have a subfield of this, deep learning, which works much better than these rest. Okay, machine learning has been working and it has been used by companies for a much longer time. Deep learning became possible since just 2012. It became profitable even a tiny bit later that, and it has become accessible to everyone since TensorFlow library and PyTorch libraries have been created. So all of these things, they are so recent that until before that, if a person wanted to learn this, it was not even possible, or do some program, it's not even possible. Okay, it's hard to imagine life before a certain time period, but as you can see, all of this power, it has become accessible only now, and that's so great. So that's the reason of deep learning. So this was, why learn AI, and by trying to just combine this section with some other slides, and Andrew Ng talked about in his other lectures something on deep learning specialization, or you could go to just CS220 website, and here there are some lecture videos which are available of 2018 lectures. So you can go to these sections, and why learn AI will have these lessons. I really thought that was a great lecture. It gives a lot of context about things, and it does go into fundamentals of some things, like other ways of doing AI, what they are and how they are progressing. And the graph of that, it's actually, I don't know why it is not here, but we'll compare. We have a graph in next lecture, actually comparative, which field has picked up how much in past years. So we will elaborate more on that on a deep learning specific lecture, like Andrew Ng has.